Okay, here's an indefinite integral that's in the section on integrals using partial fraction decomposition. And it doesn't look right away like this should be a partial fractions type integral because it's not a rational function. But it actually is a rational function in disguise. It's a rational function in terms of e to the x. It's easier to see if you actually start by doing the substitution. So we're going to set u equal to e to the x, and then du is going to be e to the x times dx. And notice that e to the 2x up here, remember that that's just e to the x times e to the x. And so that's how I'm going to handle this. We're going to have like one of the ex's is going to be the u, and the other ex is going to be paired with the dx to be du. So after making that substitution, I'm going to have the integral of u du on top, right, because I had the e to the 2x and the dx. That's where that went. And on the bottom, I have 2u squared plus u minus 3. And I need a no, I have a du on there, no problem. Okay, so now what I'm going to do actually is I'm going to factor out that bottom quadratic. So I have the integral of u over. And this guy factors out real nice. The 2u squared means that I'm going to have a 2u and a u. The minus 3 means I have to have a 3 and a 1 with a plus and a minus. And as I do that, I can just guess and check. I get 2u plus 3 times u minus 1, and then I'll put the du off to the right. Fantastic. That means we're ready to begin the partial fraction decomposition to get this guy, this rational expression, split up into two pieces that I can take antiderivatives of. So going off to the side to do some margin work. I have my rational expression. It's just two linear factors on bottom, so there's only going to be two pieces over here. Two unknowns, so I have a capital A and a capital B, and I'm trying to figure out the numbers that capital A and B are going to be. I multiply both sides of this equation by the quadratic, and so on the left, the top cancels with the bottom, and I get just the u. On the right, I'm left with u minus 1 times a, right? The 2u plus 3's, they cancel. And then I have plus 2u plus 3 times b. It's always smart to rearrange this, right? So I'll distribute everything. And then I have a times u, so here's the a times the u, and then there's the 2b times u, right? So I just like rearrange these terms. And then I have plus 3b minus a. Well, that's fantastic. What that means is a plus 2b equals 1, and the 3b minus a has to equal 0 because there's no constant over here on the left-hand side. I'm going to choose to solve this system of equations by adding, and the reason that I'm doing that is because I see an a and a minus a, so I know they're going to cancel. And when I add those equations, I get 5b equals 1. So that tells me that b equals 1/5. And when I plug that into either one of those equations to solve for a, I get that a equals 3/5. Now, I am done with the partial fraction decomposition. I go back to my problem, and I rewrite my rational expression as these two other rational expressions with the a and the b where they should be. And this is fantastic because both of these are actually ln type derivatives. They can both be integrated easily. And so I'm going to do a whole bunch of work at once. So there's my 3/5. The antiderivative of 1 over 2u plus 3 is actually equal to 1/2 times the ln of absolute value, 2u plus 3. And this guy, here's the 1/5 from above, and then there's ln absolute value u minus 1, and then I have a plus c. And I only have one more step to do, which is to put the e to the x's back in their spot. A couple of notes here. One, I didn't try any kind of simplification because, as you know, these two things are added, the 2ex plus 3, so it's not like I can distribute the ln in any way. That's not a valid thing to do. So I'm not even going to touch this in terms of that simplification. Secondly, this problem is finished, but notice how I have parentheses around this expression and absolute value bars around this expression. Why did I change these bars to parentheses? And the reason is because 2ex plus 3 is always, always, always positive, right? You know that e to the x is always going to be positive even when you plug in negative numbers. And when you multiply by 2 and add 3, you're definitely positive. On the other hand, e to the x minus 1, sometimes that's negative. I think if x is less than 0, then that expression is negative. So there's no way that you can remove the absolute value bars. I'm not saying you have to change the bars for parentheses, I just chose to.